I'm Carl Anthony, and welcome to InCabin, the groundbreaking new event and community from Sense Media, the creators of AutoSens. InCabin supports the knowledge and connections for automotive in-cabin technology specialists across the globe. One such specialist joining us today, Jan Martin Juptner, who is the Business Development Manager for Sony Depth Sensing Solutions. And Jan, welcome and thanks for being part of InCabin today.
Yeah, thanks a lot. Nice to meet you. And I'm also very happy to be with you here today.
So Jan, give us an overview. Tell us about the work that Sony Depth Sensing Solutions is doing right now in the automotive industry.
Yeah, so Sony Depth Sensing Solutions is a part of Sony Semiconductor Solutions. So we are 100% part of this group. And what we are doing is developing several sensors and sensor solutions, so including the hardware and the software. And at this event particular, as is the in-cabin event, we want to promote our in-cabin solutions. And as STS is focusing mainly on 3D ITOF technology for the moment, we want to introduce you into the technology today. And it all started with this ITOF technology since 2015, when we were first time in automotive with the gesture control. And since that time, we were starting with this more comfort related features, but going then into the safety topics since the few years, as we see that also safety is getting more and more important in the in-cabin. And that's why we increase also our development and knowledge in this safety topics.
Jan, let's talk about 3D indirect time of flight sensing. So kind of a two-part question here. First, what is it? Can you give us an overview of the technology? And then second, what are the applications and use cases and why is it beneficial?
Yeah, very happy to hear that question. So 3D time of flight, indirect time of flight sensing is a technology where the sensor is detecting light. We send out actively illuminated light. It's modulated light. And this light is sent into the in-cabin of the car, then reflected by the interior or also by the human or by the car environment, sent back to the sensor. And due to this, as it is a modulated light, we can see the phase shift of this light. And then due to the phase shift, calculate the distance to each point of the car. So each pixel from the sensor then accurately can detect the distance, and therefore we can create the full in-cabin in a 3D volume, or how we call it also, in 3D depth model of the in-cabin. And the advantages there is that we very reliably can track the full interior. We can see clearly the distances. For example, if we start from our topic where we originally, since 2015, are in automotive, is this gesture control, which works very reliable. And there we see or want to increase the value of the full system also in the safety, in the safety solutions. And there we see we can accurately track body posture. We can see where the head is orienting, where are the hands, are the hands on the steering wheel, are the feet on the dashboard. So really these safety topics where accurate distance measurement is necessary, we can provide that.
It's an excellent explanation, Jan, of 3D indirect time of flight sensing. In addition to that, you have software and hardware solutions for your customers. What are some of the main advantages of these Sony software and hardware solutions?
Yeah, that's a good question. So as said before, we can provide several sensors for interior, exterior, 2D sensors, 3D sensors. And where we see the particular advantage now from Sony Depth Sensing Solutions is we have knowledge about this sensor technology for the in-cabin since 2015, especially for these sensors like active illumination. We know how the LEDs or VCSELs need to be controlled actively, and that's also how we call it. We have several advantages in our portfolio. One is this camera reference design, so we really know our sensor, the Sony sensor, is developed by Sony, so we really have the knowledge to combine it with the active illumination, and as well have the additional software on top. So it's really the full solution out of one hand, which we